welcome to Silax, the podcast where we talk about scientific developments and technological changes in Luxembourg. And in today's episode, we talk to Ben Thuy, the paleontologist from the Museum of Natural History in Luxembourg. And he told us a lot about different excavations, working as a paleontologist in Luxembourg, his involvement in the museum exhibitions, brittle stars, which are quite fascinating for him especially. And you will see, he actually did get me interested after the discussion. And also other things like naming new species. I hope you enjoy the episode. Hello and welcome to Silax. Our guest today is Ben Thuy, the paleontologist at Luxembourg National Museum of Natural History. Thank you for coming today.
It's my pleasure. Thanks for inviting me.
Okay, I have to start with something strange or surprising. So my question is, are you mourning right now? Are you sad?
Why should I be?
Because the Lost Ocean exhibition is just finished. And I don't know,
yes.
What is more important for you, the excavations or the exhibitions? But that was quite a lot of work for you, wasn't it, at the museum?
Oh, yes. Yeah, absolutely right. Well, I'm having mixed feelings right now. It was a very intense time. I think it had a running time of 8 months, and every single month was very intense and very workload and full of activities and presentations and guided tours and excavations lately. So I'm going to miss that. But on the other hand, I have to say, that was enough now. I'll need some more time for actual research, which nevertheless continued during the exhibition time. But still, it feels a little more quiet if you don't have a big exhibition in your back, needing attention, needing activities. So yes, I'm mourning, but I'm also relieved to some extent.
So now you have to dismantle and then you can actually focus on something else, I guess, as you said. All right, but before we discuss the exhibition itself, because I also wanted to focus a little bit on that, because I have to say that I loved it. Myself was there twice. So it was really worth it. I just wanted to set the scene as usual. And as I said, you're the paleontologist at the museum. Can you explain to our listeners what is paleontology? I know you get that question so often, but I still have to ask.
Oh, it's quite correct to ask, because there is always a bit of confusion between paleontology and archaeology. The definition of paleontology is the science of the past life, the science of past living beings. And that's quite an accurate summary of what we're doing. We're looking into how life was millions of years ago. So by definition, we are also dealing with dinosaurs, or at least the non-avian dinosaurs. But when it comes to human activities, human culture, human buildings, these are the topics of the objects of study of the archaeologists. And people tend to confuse the two, because we are both digging the soil, but with different techniques and different aims. So yes, we were digging, and yes, we were also collaborating with archaeologists. But when they stopped, that was when we started, namely with the ground rock. That's where our stuff is hiding in.
So it's all about digging, but the aims are different. You just don't care that much about people.
I wouldn't say so, because, well, what we're digging is the archive of life. So we are investigating it because we care about nowadays. I mean, there is a very pathetic phrase that says that the past is the key to the present, but it still holds true. I mean, if we want to understand what is going on around us, if you want to understand climate change, for example, we need to look into the past, because it will tell us. It will teach us a lot about what is going on today and what could be going on in the future. So caring about people, about society, is definitely part of the game. But when we are digging, of course, yes, we are not expecting human remains.
There will be a lot of assumptions in our discussion, because, your job definitely has this kind of a special legendary mode, let's say, what people know about it. And of course, when you talk about paleontology, the first thing that comes, dinosaurs. The second thing, digging, as you mentioned, right? And then there are a few other things that I would like to kind of debunk, let's say, discuss these myths, and also talk about other things that actually you could be focusing on, because you don't focus on dinosaurs yourself, do you?
No, I'm not. I've been part of a dinosaur digging team couple of years ago. That was quite an experience, I have to say. But scientifically, when we speak about my own personal expertise, it's not with dinosaurs. It's with a completely different group.
And that is?
That is the brittle stars, which are one of the five living groups of echinoderm. They are the cousins of the starfish and of the sea urchins. They have a very rich fossil record, and especially they have a very poorly studied fossil record. So they are a bit like a playground that nobody has used before. So and that's making them interesting for me as a model organism to study in order to understand the big picture. So dinosaurs are still very useful, and I still deal with dinosaurs, especially when it comes to science outreach, because they are the perfect ambassador. They are the charismatic group that you can use to get the people's attention. But once they are listening, I tend to go to my own expertise, because that's where I really can tell the stories, the innovative stories that I'm part of as a researcher. But you're not going to make the headlines with a brittle star. Let's be honest; it's not a group that people are very familiar with. It's not even remotely as spectacular as a T-Rex. But for scientific research, I would say they are at least as exciting as a dinosaur.
Okay, so let's prove how exciting they are. I know you prepared a pub quiz question about them, so could you ask it right now?
Yes, yes, yes. Cool idea, by the way. I like this concept. And my pop quiz question is: brittle stars have three superpowers. Can you imagine which ones they are?
Okay, great question. And as usual, please remember that the answer to this question will be only at the end of the podcast. So it's really worth listening. Of course, there are other reasons to listen as well, but also the answer to the question will be there. So now coming back to the basics. So we discussed a little bit brittle stars. We are going to definitely dig deeper into it, but I wanted to come back to paleontology as such and the fact of digging. Because as I said, we have this assumption that, okay, if we already understand what is archaeology and paleontology, then the other thing is, okay, dinosaurs, and the second or third thing is digging. But it's not necessarily only that, right? I mean, there are a lot of modern methods that you're using. It's not that you spend all your time with a small brush. How does it look? Explain to me, because that's very interesting.
Well, this is the Jurassic Park moment indeed, because I don't know if you remember, one of the first scenes of the film is when the paleontologists, which by the way were my idols back then as a child, they are lying on the floor and brushing a skeleton of a velociraptor. I can tell you, I use the brush, but not in the fields. It's very, very, very exceptional that we actually dig with a brush. We dig with an excavator. We dig with the heavy materials. And if it comes to the detail, we don't do that at the quarry. We don't do that in the field, because the chance is very high that it's going to end up in a damaged fossil. So, field work is heavy physical work, and then the fine work is done in the lab. But when I'm using the brush, it's when I'm picking microfossils. I'm picking them with the finest brush that you can buy in your art shop. And why a brush? Well, for the simple reason that the fossils, the microfossils, the tiny millimeter-sized fossils I'm trying to extract from my sample, they tend to be very small and delicate. And if I can use a very small brush, then I can manipulate it and extract it without risking any damage. So yes, I'm using the brush, but not in the way people imagine.
Okay, so but you're not a excavator operator either, right? You have other
No.
people doing that for you, or how does it work?
Unfortunately, I'm not. But during the last excavation, for example, we were in the extremely lucky position to have a very skilled and a very, how to say, motorically gentle but still efficient excavator conductor. He was extremely efficient in the way that it took him half a day to learn the geology of the site without being an academic at all. And he was able to operate the machine in a more gentle way than some people use their hands. So I'm not I'm not driving those machines myself, but I have a very high appreciation if people can do that in the context of an excavation.
And then, for example, you mentioned that in the recent one. So the recent one was the one in Basharash, right?
Correct, yes.
Okay. So just to understand, was it because what I read about you, because I have to say, okay, let's start with that. I have to say that you are very present in social media and there's a lot to find. I would say almost famous, or maybe it's just because I'm checking the museum site like crazy and on the Twitter account and everything. So I'm a big fan. So I see you very often and I see you there, showing all the fossils and everything you found. And what I understood from what you were explaining as well is that you either well, you can go look for them yourself, but most of the times what happens is that there is, I don't know, a new building constructed, right? Or there are some amateur fossil searchers who find something and then you get called and you go there to examine it yourself. Am I right? Did I get it correctly?
Yes, that's a very accurate summary of how it takes place. For the simple reason that I cannot be physically in more than one place. So I have a lot of admiration for Dr. Manhattan, but I am most of the time I am at the museum at my office. So if there is an interesting place gaining momentum in the field, meaning that there is a construction site or there is a landslide sometimes even, or any kind of outcrop, then it's normally one of our collaborators who tell me, who raise awareness, and then it's that moment that triggers an excavation, if at all. It's not very common that we actually go and have an excavation. And I can also tell you that the last 2 week, the 2 week excavation we had in Basharash, that's really an event. That's really something that takes place every 10 or 20 years for a couple of reasons. First of all, there is very few places like this where you can actually have a fossil Lagerstätte, so a fossil concentration as shallow as just 1 meter underneath the surface. So this is really an exceptional situation that you don't have around every corner. And the second reason, the second very practical reason, is that the fossils we unearthed now will keep us busy for a couple of years, at least. So if we have the wrong ratio between digging and working, we will end up just accumulating stuff that the following generation has to clean up. And we want to keep it fair and feasible. So we go digging whenever there is an opportunity or whenever it is necessary, like in this case, because if we hadn't dug in Bacharach, the site would be covered by buildings, so it would be inaccessible. So we didn't really have a choice. But if we do a digging like this, it will really, really create a lot of work for years.
In this particular case, were you informed by the people who are doing the construction work there, or what happened? How did you end up there?
It was a very lucky combination of very gentle-minded and attentive people from various places. First of all, it started with one of our longest-lasting collaborators who lived not very far from the site and who noticed that there were archaeological prospections going on. Archaeological prospections that are prescribed by law before before construction work starts. And the second lucky strike was that the archaeologists involved were, I would say, friends of us. We have a very good relation between our departments, and they told me that I should come at the very moment they are opening the pits and have a look at the interesting trench. And it was indeed the moment to be there to really get an impression of how the underground will look like. And then the third lucky strike was that the person in charge of orchestrating the construction project at the economical ministry was very supportive and very helpful when it came to organizing access authorization and orchestrating the schedule for this in order to make it happen. So it was a very lucky coincidence. A lot of talking to people, a lot of having to deal with people who like the idea of this excavation, and then it could take place.
Okay, and it also means that now you have enough work for a couple of years, as you said, so all the other construction works can go unnoticed and they can do whatever they want because you won't go there because you don't have time and possibility.
I wish it was as simple as that, but we also don't want to miss opportunities that are unique for the simple reason that it is our mission, our legal mission, that we have to keep an eye on the paleontological legacy of the greater region of the country, especially. So if we are unlucky and there is going to be another construction just opposite this site, then we have to do that again, because otherwise, well, if it's possible logistically, but yeah, we just hope that all the constructions for the next couple of years will be in geologically uninteresting areas.
Meaning the north of Luxembourg.
That's not, unfortunately, not as simple as that. No, no. There is very interesting places in the north of Luxembourg, but they are more scattered and difficult to localize, and more difficult to predict because of the particular geology of the northern part of the country.
Because, maybe some of our listeners don't know that, but in general, when you have excavations, it's more often in the south.
Not necessarily, no.
Okay, so I misunderstood that too.
Well, it's easy to get this impression, because the southern part of Luxembourg is, of course, very rich in spectacular fossils. If we're talking fossils from the dinosaur time, from the Jurassic, if we're talking fossils from big vertebrates like marine reptiles, they are all from the south. So let's say the headline material comes from the south, but scientifically speaking, we're also having very, very interesting material coming from the northern half of the country. And we did have an excavation in November in the area of Heiderscheid, even with an excavator, with the same conductor, by the way. But it was not an opportunity to call the press, because it was very difficult to sell the popular interest, the scientific interest, to a lay audience. So we had a lot of we excavated a lot of very exciting and scientifically very, very valuable fossils, but selling these from an outreach perspective would have been much more difficult than in Bacharach.
You also mentioned that whenever there is a new construction work, there have to be archaeologists on the site, but they also need to cooperate with you. Does it mean that paleontologists are like second in line? Nobody will inform you and you just don't come and check yourselves? No, there's no law for you?
Paleontological research is covered by the same cultural heritage law as archaeological heritage since recently. That's the recast version of the law, but we are not second in line. That's I would say so, but logically, from the succession of works, we are of course coming after archaeological research, for the simple reason that we go deeper in the rock. But there is definitely no weighting of the value or prioritization or anything alike. And then it's also our research is based on the geological units that you have in the underground. And most modern constructions tend to avoid going too deep underground for economical reasons, whereas archaeological heritage is in the very first layers of the soil. So it's much more often to encounter archaeologically important stuff, even though you don't go very deep, than paleontologically relevant material. But I would consider it as a very fruitful collaboration between experts.
Sounds way better than what I understood in the beginning, because you said, well, we had particularly friendly archaeologists. So I needed to ask what was going on there. And also, you mentioned that it involves more digging, but aren't there new technologies nowadays where you can just scan bits of land and see what is inside? Are you using these too, or not in this particular case?
Well, as a child and still nowadays, I've always been dreaming about these goggles, these scanner goggles that will show you where the fossils are. I think in Bacharach you would have gone crazy with these, because they would show every single ammonite in the soil and in the rock. And I can tell you, we found hundreds, thousands of ammonites. So the underground would be bright if looking with one of these goggles. Unfortunately, there is no such device. You can use scanners to scan the underground, but there is a very, very, very low chance that it will show you the position of fossils, because in order to be detectable, it has to differ in one way or another from the rock. And it only does so if if there's a noticeable physical difference, for example, a difference in density, which is normally not the case with the fossils that we look for. But having said that, I can tell you that some Patagonian dinosaurs were found with a Geiger counter because they were radioactive. The scientists were not looking after dinosaurs, but they were looking after uranium deposits. And vertebrate bones, especially the large ones, they tend to accumulate very heavy elements during fossilization. And as you probably know, uranium is a very, very heavy element. So in this case, they accumulated uranium like a sponge. And as a result, they were detectable because of their radioactivity. But this is an anecdote for sure. So there is no real alternative to digging.
Who knows? Maybe there will be a new technology soon.
Maybe there will be, yes, but we'll still need to have some fun.
So you consider this digging fun then?
Oh yes, it is. It is. If you spend most of the time in the lab or in your office, digging is the fun part. It's the physical part. It's the part that that reconnects you with the rock, that reconnects you with the outside, with the elements, and it's also the moment of discovery because you're unearthing something. I mean, who has never dreamt of unearthing a treasure? I mean, this is a childhood dream. So yeah, of course, this is fun, definitely.
Absolutely. But the treasures you chose, as you said in the beginning of the podcast, were the brittle stars. So now I have to ask, why brittle stars and not something else? I mean, as you said, the uranium in dinosaurs, that just works, it's wonders. You can sell it way more. People get more excited. That with brittle stars, I mean, yes, but how do you sell it to people? Why brittle stars? Yes, let's start with that.
Yeah, yeah. Well, why brittle stars? It started during my early days as a citizen scientist, as a youngster, when I was mainly interested in just collecting fossils, and then came the moment when I decided to go a bit take it a bit deeper and write a scientific report about one of the fossils I found and submit it to the Youth Science Contest in Luxembourg. And I wanted to know more about this particular fossil. It was a fossil sea urchin from the south of Luxembourg, and I wanted to look for remains of the predators of this sea urchin, namely the sea stars. And you find the sea star elements when you take a bag of mud and you sieve it, you screen wash it. Then you find the plates that compose the skeleton of a starfish. And I did find a few starfish plates, but the sample was completely filled with weird looking small fossils that belong to a completely different group, to the brittle stars. And then another collaborator of the museum, gave me some literature on these plates. And first of all, they intrigued me because of their shapes. And second, I was amazed that something that abundant, something so easy to collect, was so little known. So it occurred to me that this could be really like a Pandora box that nobody's ever opened before, and it turned out true. So these fossils they were very, very abundant, very easy to collect, and very informative as well, but understudied. So I immediately saw the potential in this, and decided to take it to the next level and really focus on this group of animals, knowing, of course, that it's very difficult to start from, I would not say scratch, but almost scratch. And knowing also that I picked a very uncharismatic group of animals, but it's not all about selling to the general public. It's mostly about generating knowledge. And in this case, there was a lot of knowledge to generate and a lot of cool stories to develop and a lot of new things to discover that could potentially be relevant for the greater picture. And that's exactly why I haven't stopped ever since, because the potential of the brittle stars is just enormous.
And we also mentioned them in the pub quiz question, but yet we are not going to reveal exactly what you meant with the superpowers. But I wanted to ask, did I get it correctly? It started with the Young Scientist Foundation?
Yes, exactly.
Okay, because as you may know, recently we interviewed one of the finalists of the awards, Sky Beck, who talked about cancer and angiogenesis. That's episode number 20, and we are
Yeah,
also following a lot the young scientists because they are doing really cool things. So it's
that's
good
right.
to know
Yeah,
that
yeah.
your professional life also started with that association.
Yeah, absolutely. I can really say that It did make a difference back then because it was my very first attempt at writing a scientific report, working using scientific methods. It really gave me an impression of what it is like to do research and present and defend your research. So, for those who think about entering the world of science, taking part in this contest as a young person really makes sense because it's an excellent playground to explore this world and take it to the next level
Yeah, absolutely. And a lot of fun as well, because
and
as
have
you
a lot of
said.
fun and discover what you like and what you don't like.
Okay, so that's brittle stars. Once again, I don't want to get into too detailed discussion because then I'm afraid we were going to reveal the answer. But I wanted to ask you also, as far as I understood, you also found some new species of brittle stars, haven't you?
Yes, that's difficult to avoid if you're studying a group that has been neglected for centuries. You all know that every known organism on the planet, whether alive or extinct, has a name. For the simple reason that we need to name things in order to work with them. If we start numbering the animals, it will get messy very soon. So, giving names to an organism is the very base of dealing with biodiversity. So, in order to explore the evolutionary history of brittle stars, I first had to start describing the species that were undescribed before. And I don't want to brag here, really, but for one of the presentations I gave during the last month, I had to check the number of species that I had the chance to name, and I'm at a little more than 100 now. So there is a lot to discover. I'm not exaggerating, and describing species can be fun, but above everything else, it's a lot of work because it's a very formalized process. You have to follow some rules set up by an international code of nomenclature, that guarantees that these names are scientifically valid. They are scientifically provable and testable hypotheses.
Okay, so first you have to actually prove that this is a new species, and then
Yes,
also.
yes. You have to argue why you think this is a new species, and then you have to follow a couple of rules, including the designation of a type specimen. So you have to tie your new name to one designated specimen, one individual, one piece of fossil, because if you don't do that, it will not be testable. You cannot go back to this concept of a scientific name and check if it is really a different species or if it's maybe just a variation of an existing species. And then you have to follow a couple of other rules, including the designation of or the definition of the relevant characters, the definition of the precise origin. You have to illustrate your new species, and then you have to follow a couple of rules crafting the name of the species.
And what are the rules for the name? Because obviously, all the journalists are going to ask you that. And of course, if people have been following you, they've noticed that you kind of combine science and music. So I have to ask about the rules because then I know that you've done something cool about the naming.
That's right. The rules are luckily just few and quite relaxed. If you want, you have to have a species name with a minor and a genus name with a starting with a capital letter. Other than that, you have to use the Latin alphabet, so no accents, no special signs, no numbers. The species name has to have at least two letters, which is obvious. It has to be pronounceable, whatever that means. I think it's more subjective. It must not be offensive, so you must not mock somebody or, I don't know, use a name that is politically incorrect or a personal offense. But other than that, you're free to go for whatever you want. So you can come up with fantasy names that have no meaning at all. You can use boring names like, I don't know, use a character of the animal and say, okay, this is a very tall animal, so I'm going to call it Maximus. It's a very small animal, I'm going to call it Minimus. It's I don't know, it's a spiny animal, so it's going to be called Spinosus, or it's from Luxembourg, I'm going to call it Luxembourgensis. Yes, that's fair, that's scientific, that's normal, it's often done, but it's not very exciting. And let's be honest, naming things is not the most exciting part of science. It's a very dull aspect of paleontological and also biological research, and the species descriptions are very hard to read. I don't read them unless I have to. I have to be honest. But you can add some flavor. You can spice things up when you have funny names. And you already anticipated my thing in this case is that I name species after my favorite bands for the simple reason that I can do that and it's fun.
And all the 100 species are named after your favorite bands?
Oh, I don't have 100 favorite bands, so no. There is a lot of species that have different names. Some of them have compromise names if the co-authors were not as keen as me to name things after musicians, especially from the metal scene. Some of the names honor colleagues or friends or relatives. I even named one species after my dog because he was a very supportive personality during my PhD. So it is an authentic move to honor him. But no, a couple of them, quite a number of them, bear names of my favorite bands and musicians. And it turned out that this is not only fun; it's also a very nice way to do some science outreach, because if you pick bands that are still alive, still active, and musicians that are still alive, and you contact them, there is a chance that they will be excited about them being the name giver of an extinct species, even though it's not a dinosaur. But then again, it's also not an intestine parasite, so it's not a shame to be named to have a brittle star named after yourself, and it's a cool way to have some headlines even as a musician. So this is a way of building bridges between science and culture, and it occasionally works very well, to the point that we can raise awareness for both worlds, show that both worlds can inspire each other, have a certain form of cross-pollination, and make the music fan aware of science and make the scientist aware of some genres of music that he or she would normally not listen to. So it's a winning game for both sides.
So you're saying that heavy metal and metal are not popular among scientists?
Well, among scientists certainly, and ironically, it's especially the earth scientists who are very much listening to rock music and metal music. But the science enthusiast, the scientifically interested lay audience, is not necessarily the one that you find in the rock hall.
That's true, although I've spent a lot of time with IT specialists, and that is also quite at least in Poland, where I'm from, it was pretty popular type of music.
There might be an explanation for this. People who listen to heavy music, who listen to metal, they have a very strong, well, it's scientifically proven, they have a very strong sense of ordering things, a very strong sense of trying to understand chaos and trying to see the pattern in things. So it's not a coincidence, I would say.
Okay, another scientific explanation. I was not expecting that about heavy metal music or rock music, because I haven't heard it before. But good to know. I'll think about it a little bit myself as well. Why I like such music too. But it's also actually, from a personal standpoint, a great occasion for you. Let's say, right? Because you can meet some of your favorite artists.
Oh, that's right. Yeah, that's a very cool side effect, and it actually worked out in a few cases. Although I have to say, this is not the primary goal.
Of course.
The main goal is to have fun. The main goal is also to make a scientific species description more interesting, and to show that there is ways of spicing up things and creating inspiration well beyond the border of what people expect. So simply worded, I would say it's a way of making something quite formalized and dull much more interesting.
And when you talk about fun, I wanted to go back to the discussion we had in the very beginning. So the Lost Ocean exhibition and all that. As I said, from my standpoint as a visitor, it was a lot of fun. It was a really great exhibition. Congratulations on that. But I'm sure that you also, except for hard work and being tired right now and all that, you also had a lot of fun with it. So could you tell us what was your favorite part of it? Was it the outreach activities, the different presentations you've had, maybe certain part of the exhibition? What was the best for you?
That's a good question. I have to say, I haven't had enough distance to really point out an all-time favorite here. I have a few favorites, I would say. First of all, the time of setting up the exhibition was a magical time, absolutely, for various reasons. First of all, a very fruitful and enjoyable collaboration with our graphics team, who did a brilliant job. Really, absolutely, it was wonderful, and it was very cool to see the exhibition grow bit by bit and take shape. So that's definitely one of my favorites. And then I'm absolutely in love with the plesiosaur model because it turned out just so cool, much better than expected, and yeah, that's definitely one of my favorites. And I also very much like that our concept of the Lost Ocean Lab, the scientific working place within the exhibition, that it actually worked out. And that's something I'm very fond of. And finally, I have to say, even though it looked as if we had planned this in advance, but I'm also happy that the end of the exhibition was an excavation in exactly the same rock that we displayed. So it was a very good way to end this project.
Yeah, that's what I was planning to ask you exactly, whether it was planned because it just exactly happened at the right moment, right? So,
Yeah. No, I wish it was possible to plan such things in this way, but in this case, it was just a very lucky coincidence that we of course used. But yeah, it was not planned, I have to say.
and for those who haven't seen the exhibition, I also know there is a book that you published. Is it
Oh
still
yes,
available in the
yes.
museum shop?
I have to say, this is also one of my favorites because it was a lot of work, but the result is making me quite happy. It's a book that is not a catalog of the exhibition, even though it follows the path of the exhibition in that it shows the way of a grasshopper that ends up as a fossil, and on the way from the island, the Jurassic Island, to the bottom of the Jurassic Sea, it encounters all the animals that we showed in the exhibition. And the book can be purchased at the museum shop, even now that the exhibition is closed, because it is a book mainly about one specific type of fossil Lagerstätte that we have in Luxembourg, and also a book about paleontology in general. So for those who are interested, the book is available. It will be available in the weeks, months, and years to come, and it will also be available online, but I'm not sure if I can already promise this. It's bound to some technical issues to be solved, but sooner or later you will also be able to buy it online.
I'm definitely interested. I only have seen the cover, but it already got me intrigued. So probably will go to the museum shop, probably without my kids, because when we go to the museum shop, we always end up buying a lot of stuff because there's a lot of nice things for the children as well. So
That's what a museum shop should be like, isn't it?
that's also true. Yes. Some treats at the end. Why
Yes,
not?
yes.
Okay, coming back to the excavation you mentioned, so the one that you kind of finished the Lost Ocean exhibition with, what did you find there? Because that we didn't discuss. You said that you were very excited, it was amazing and whatever. So what were the special findings there?
It's a twofold answer I'm giving now. First, physically, specimen wise, I can say that the most exciting things that we found were some fossil fish specimens that are quite rare and that already now seem to be preserved in a very exceptional way, so that after preparation of the fossil, we will be able to see some amazing anatomical details. Then we found a lot of fossil squid specimens with the soft parts preserved, including the mantle and even the ink sac. We have fossilized ink, which is not unknown before, but it's always very exciting to find it. And then one of the squids seemed to have the last meal in the stomach, consisting of a small fish. So this is a fossilized drama, if you want. It's a fossilized crime scene, and it's making it very exciting. Then something unexpected, we found a fossil pine cone, which sounds quite common now, but it is not. It's fossil pine cones from this period, from the lower Jurassic, they are extremely rare. You wouldn't normally find them in the marine rocks. And thinking about it, in order to have a pine cone floating all the way to the middle of an ocean, sinking to the floor, and being preserved as a fossil is something quite exceptional. And a pine cone can be used to identify the plants that we are dealing with. It gives so much more information than, for example, a piece of wood. So, scientifically speaking, this is a very exciting discovery. And then, of course, not to forget the more popular things and the spectacular things, we also did find a few specimens of marine reptile, including one partial skeleton of a young ichthyosaur. So, when it comes to specimen discoveries, this is really something that we can be proud of. We have a lot of very exciting discoveries. The second part of my answer is we discovered a treasure of information. Really, it was a scenario that was unique because we could do something like an autopsy of the Lagerstätte. We could really dissect it layer by layer, and as a result, we now have a much more complete picture of how these fossils can be put into the context, into the geological and the paleobiological context. So we know which animal lived during which period, we know which animal lived together with which other animal, and we were able to collect samples for all kinds of analysis from the top to the base. And these analyses will include, for example, the study of the climate at the time. So we will know within the next months what the climate was in this area, and Bacharach will therefore contribute to a better knowledge of the lower Jurassic climate worldwide. So yes, we found a lot of fossils, but we also found a true treasure chest of information.
And it's very important that you mentioned this, because we have this tendency to focus just on the fossils themselves, right? But there is also the study of paleoecology. Am I getting
Yes,
it right?
exactly.
So the
Yes.
whole idea of climate and what we can learn from the past as well. So this is especially important right now that we are noticing all the problems with biodiversity and climate change and all that. We can really learn a lot
Yes,
through
yes.
that, these kind of information.
Absolutely, and that's why this excavation situation was so lucky and so important, because when we go to a construction site, we normally have no control about the extraction of the rocks. So we can look for fossils, of course, and we regularly do so. Like, for example, during the construction of the new prison in Sanem, we were able to collect a lot of scientifically important fossils, mostly from insects, including new species, by the way. But the material was already excavated. It was already on a pile, so we could not reconstruct the context, the geological context, in as much detail as we could do this time. So we had full control over the process of extracting the fossils, so we could really document in every detail where the fossils came from. And just to give you an example, we found a lot of fossil wood, driftwood, even one tree trunk, a big tree trunk. And if you find it on the pile of debris after construction, well, you would say yes, it's fossil wood. It's nice to have. But since we could extract it, since we could unearth them in situ, in place, we were able to measure them, measure the direction, the orientation of these pieces of driftwood. And they happen to be all oriented along the same axis. So we have a clue about the ocean currents back then. And this is something you don't get if you're exposed to the oddities of construction work. This is only something you can measure if you're digging things out yourself, layer by layer.
If I were you, I would have difficulty sleeping, because it's all the processing, what you've seen and what you need to analyze and what you can actually discover later on, so on and so forth. But I just realized, because I assumed, well, I've been to the exhibition, you participate in the Lost Ocean exhibition, but we haven't mentioned, maybe for those people who don't know, why are we talking about an ocean in Luxembourg? Water? Sea? What's going on? We didn't say what was here before.
Yes, well, most of the rocks that you see around when you drive across the country were deposited at the bottom of an ocean in one way or another. Even in the north of Luxembourg, the the slate that you see along the roads, ravines, and the outcrops, they were formed, they were deposited on the bottom of an ancient ocean and then lifted to the surface. And in case of the slates in the north of the country, they were even part of a mountain chain millions of years ago that nowadays is, of course, eroded down to some gentle hills. But yes, the part of Europe that we nowadays call Luxembourg was covered, at least in part and in times, by an ocean that was mostly shallow. So all the sandstones that or most of the sandstones that you see, especially in Luxembourg City, and all of the rocks that you see in the southern part of the country were part of an ocean. Whereas, especially during the lower Jurassic, so during the time that was portrayed in our Lost Ocean exhibition, the northern part of the country was part of an island, so it was above the sea level. But yeah, due to tectonical movements, due to shifts in the sea level, much of Luxembourg was covered by an ocean, at least from 230 million years ago until 268 million years ago, with a short episode between when the sea level was lower and when we had terrestrial deposits in the Triassic. So yeah, it's quite a fluctuating history of sea level change, tectonic movement, and varying past environments, if you want.
You mentioned it was shallow. Can we say more or less what that shallow means?
Shallow for an oceanographer or a geologist is above 100 meters.
Okay.
It's still too deep to scuba dive. I mean, going deeper than 30 meters is just something for experts in general. But shallow means it was exposed to storm activities, so you can see the traces of storms in these rocks. And shallow also means that the sunlight reached the seafloor all the way through. If you go below 200 meters, you're talking about, you start to talk about the deep sea, and that's normally the depth where the sunlight ends. So here we were all above this depth. It was all very shallow. And it's also one of the reasons why we have this particular fossil collection that mostly consists of animals and plants that lived in the coastal areas.
I could go on forever. Unfortunately, I always say it. I always promise myself that in the podcast, I will not repeat the same sentence, but I just love talking to the scientists so much. I would have so many other questions to you, but well, we are kind of slowly running out of time, and we also need to solve the pub quiz question. So to discuss also about brittle stars a little bit more. So could you repeat the question? Hopefully you still remember it, and then give us the answer.
The question I asked in the beginning was, which three superpowers do brittle stars have? Well, to start with, what is a brittle star? Because I doubt that most people are familiar with this group of animals. They are the I tend to say they are the slender-armed cousins of the starfish. So they look like a starfish, but they have very slender, very mobile arms, a central body that is disc-shaped, and they can move quite fast. So if you happen to find one at low tide on the beach, you will be surprised how quickly they can escape and how fast they can wave their arms to move forward. And even though they are not very popular and they're not very well known by the lay audience, they are everywhere in the ocean. There is not a single corner in the world oceans where there is not a brittle star. Even in the deepest parts of the oceans, you would still find them. And because they are echinoderms, they have an internal skeleton, just like we do, except that their skeleton is made out of calcium carbonate, so limestone if you want. And they have a lot of interesting properties, but three things qualify as superpowers. And one of them is that they can glow in the dark. So they are bioluminescent, many of them at least, meaning that they can emit flashing lights, especially when they are being attacked by a predator. And they can flash lights in green and blue colors. The second superpower is that they can split into halves and reproduce asexually. So they can do as the bacteria do and just split in the middle. And then you have two new brittle stars that are practically, well, the same as before, except that they are just two now. So it's quite a complex group of animals. They are closer to the vertebrates than to the mollusks, for example, but still they have this very, very simple way of reproducing themselves, which is quite amazing if you ask me. And the third superpower is they can see without eyes and without a brain. They can see with, some of them can see with their entire body surface. They have light detectors all across the surface of the body, but they don't have a brain to process the image. And still, they know where to go. They know where to find the crevice uh, from a distance. So I don't know how they do it. Processing visual stimuli without a brain is something that completely flabbergasts me. So for me, this is a superpower because I just cannot imagine how this works. And I'm sure there is experts who can do, but I'm this is not my part of my expertise. I just know that they can, and I'm totally fascinated by this.
I totally agree. I now understand why you went into brittle stars, although I guess the first time you found them, you didn't know about all the superpowers that just
No,
came
no, no.
later.
That's something I discovered later on, and it just corroborated my choice, I have to say. Of course, there is scientific superpowers that I can just briefly summarize. First of all, the brittle stars are an excellent model organism if you want to know what was going on the seafloor during the past million years, because they are at the interface between what falls on the seafloor and the recycling of the nutrients. And another thing that is scientifically quite interesting, and I would even say spectacular, is that the evolutionary history of the brittle stars is well known because we have a molecular insight into the relationships that agrees with the shape of the body of the animals. And this is something that is it sounds weird now, I know, but this is something that is normally not the case. The genes often tell a different story than the shape of the body of the organisms. So if something looks closely related, it could also just mean that those two animals just lead the same way of life, even though they are genetically very distant. So the genes often tell different relationships than the characters of the skeleton, the characters of the body shape. But in the case of the brittle stars, we succeeded in reconciling these two sources of evidence, which means that we have a treasure of data that we can use to explore the evolutionary history of this group and use it as an example for the big picture. For
And
the
moreover, it's one of those species that, were there in the past and are there now, right? So,
That's right. So we have a direct link to the past that goes as far as the Ordovician. So we are really going far back in time. That's what you would call deep time. So yeah, they are an excellent model organism, at least for scientific studies. For science outreach, they are a bit more tricky, I have to say, but still feasible.
no, absolutely. I hope that after today's episode, everybody is going to get interested in that and then they can contact you and discuss more also about the pronounceability of the naming, because I would beg to differ when you said that the names are pronounceable, because even the ones that you chose, I don't think I would be able to pronounce, because some of them are after quite complicated names and surnames of the rock singers or stars.
That's right. Yes, yes, I agree. And this is also due to the pronunciation conflict between Latin and the original pronunciation, for example, of Anglo-Saxon names or French names. And there is indeed a debate going on, I mean, among experts as to whether you would stick to the original pronunciation of a surname, for example, or whether you would just Latinize it while speaking. And I personally don't care, to be honest, as long as people, as scientists, understand each other, and as long as the names are inspiring. I'm not able to pronounce all of them either, and yeah, I mean, pronounceability, who cares?
Yeah, absolutely. And I can also see that sometimes maybe it's better not to discover new species because there's a lot of work involved. You can focus on something else instead of just, trying to find the name and then really argue that it's new and so on and so forth.
Yes, it is. It is a time-consuming process, but it is necessary from time to time, because otherwise, you work with entities, you work with biological entities that you cannot name, and that can be a problem because you cannot prove that they are entities unless they have been named before. So it's like tidying up before tackling the big picture, and this tidying up can be very time-consuming. So that's one of the reasons why I picked the music-inspired names, because because it's making the process a little more funny, and making the process also sellable to a certain extent for science outreach. Before even tackling the big picture. So yes, but I have to admit, I have a pile of new species that wait to be described, and I doubt that I will be able to describe them all before I retire. So yes.
Okay, so I'll just let you now go to your tidying up, as you called it, and won't take more of your precious time. But thank you very much for coming over today. It was a real pleasure to talk to you, and good luck with all the activities and excavations and species and brittle stars and everything else. Our guest today was Ben Thuy.
Thank you very much. Thank you for the invitation. Thanks for the inspiring questions. And you're not taking up any of my time, because this is not only part of my job, but it's the fun part of my job. So thank you very much.
Thank you. And this is it for today. I enjoyed myself a lot, and I hope you did as well. As usual, please don't forget to subscribe, to follow us, to check out what is going on LinkedIn and Twitter and sometimes Facebook as well. We talk a lot about science in Luxembourg, about our guests, and also check out other episodes if you enjoyed this one. This was Silux, and my name is Hanna Siemaszko.